Rack filters. Tracktion's built-in modular environments are one of its most powerful features, but they also cause the most confusion in newcomers. I find it helps to separate the concept of racks, which exist independently of tracks, and which can be viewed by toggling the Racks button in the top right corner, and their associated rack filters, which merely handle routing to and from the rack. For example, if we create a new empty rack via the New Rack menu, it initializes with red MIDI inputs and outputs, and stereo grey audio inputs and outputs. Extra audio inputs and outputs can be created up to a maximum of 48, and they can be renamed or deleted via the Properties panel, from where we can also name the rack itself. Filters can be added to the rack in the usual way, and the first filter you add to an empty rack will prompt an offer to auto-connect. If you say yes, all the filter's pins will be automatically cabled to the rack's inputs and outputs, creating extra ones if needed. These connections can then be edited manually if you need to. Filters can also be dragged into the rack from tracks, and their inputs and outputs will then appear on the filter icon, ready to be wired up. In order to actually use this rack, you will need to connect its inputs and outputs to a track. Click on the background of the rack to select it, drag the filter symbol from the top right corner of the Properties panel, and drop it onto a track. A filter icon will appear on the track with the name you gave to the rack. You should not think of this filter as an instance of the rack, however, as it can be copied to as many other tracks as you need, and there will still only be one rack. Rather, you should think of it as simply connecting the audio and MIDI signals at that point in the chain to the rack's inputs and routing the rack's outputs back again. Rack filters can also be added to the master section, perhaps if you need more than 4 filters, or they can be dragged directly onto audio clips. Selecting a rack filter allows you to choose rack inputs and outputs separately for the left and right channels, and also provides dry and wet level controls. The default setting will configure the rack as a simple insert. The left and right channels are routed to the first 2 inputs of the rack, and then come back from the first 2 outputs of the rack, and the dry level is turned off. If you are using a rack to set up a complex chain of effects, or to run 2 or more insert effects in parallel, then you do not need to change these settings unless you wish to mix some of the original signal in with the rack outputs using the dry level slider. Similarly, you could use a rack to build up a monster synth patch using several layered instrument plugs. This rack need not have any audio inputs at all, and again its rack filter can be simply dragged onto the required track, and its settings don't need to be changed. In both these cases, however, dragging a duplicate of the rack filter onto another track will probably not have the result you intended. Copying the insert effect onto another track, for example, will mix both those tracks together before running the mixed signal through a single instance of the rack and returning the same mixed signal to both tracks. If you wish to process another track with an identical but separate copy of the first rack, you will need to first add the rack to your preset list, and then create a new rack using that preset. The new rack can now be linked to a track to process it independently of the first, and the rack area will display tabs so you can switch between the racks. It is also possible to view 2 different racks at the same time by pressing Show 2 Racks. Your list of presets can be managed by selecting the rack itself rather than a rack filter, and using the preset Load, Save and Delete buttons in the Properties panel. New in Tracktion 3 is the ability to export rack presets to share with other Tracktion users, and to import presets created by other users. The new filter list contains a list of all racks in the edit, so you can create rack filters for them without having to select them and drag from the Properties panel. Another new Tracktion 3 feature is the ability to create a new rack by selecting a preset from the New from Preset submenu. The fact that racks can be shared across multiple tracks means they can be useful even with no filters inside them. Create a new rack and wire all its inputs directly to its outputs. We now have a pass-through rack that can be used to send the same signal down multiple channels. For example, if you drag rack filters onto 2 or more tracks and then enable a MIDI input on one of those tracks, you can quickly and easily layer multiple synths to create complex sounds. Alternatively, you could use the same rack to send an audio signal down 2 or more channels, either to process it with parallel effects chains, or to route that signal to multiple outputs simultaneously. Racks can also be used to access all outputs of a multi-output plug. The easiest way to set this up is to start by dragging the multi-output plug onto a track as normal. Then right-click the filter icon and choose Wrap this filter in a new rack filter. This will automatically create a new rack with the same number of outputs as the plug you selected, and will move the filter into the rack and wire all its outputs to the rack outputs. Instead of the actual plug, that track now has a rack filter linking it to the newly created rack, which will be named after the plug you chose with wrapper appended. If we select the rack filter, we can now choose which of the rack's outputs are fed through the rest of the filters on that track, including the option of none at all, which means this rack filter is now doing nothing but sending MIDI to the rack. Now I can copy the rack filter to a blank track and pick an output to feed that track. If the output is mono, choose it for both the left and right channels. Repeat for all the outputs you wish to use and name each track accordingly, and you can then proceed to mix and process the individual outputs as usual. It is usually a good idea to enable the solo isolate option on the MIDI track when working this way, so that individual channels can be soloed without muting the rack's MIDI input. An alternative solution would be to build the entire submix inside the rack, which can then be treated as a simple stereo out plug. This means you can't share auxiliary sends with other elements of the mix, but it does mean that the entire submix can be saved for future use and will load up with all plugs and settings intact. Multi-timbral synths accept MIDI data on multiple channels in order to generate several different parts from a single plug. Tracktion sets MIDI channels per clip, not per track, but in this case it probably makes sense to give each different part its own track and make sure that all the clips on each track are assigned the appropriate channel. The next step depends on whether the plug in question has multiple outputs or not. If it only has a single pair of outputs, then the balance between different parts will need to be set up on the plug itself, and in this case the easiest way to set it up is to put the plug on a blank track and then route all the tracks with the MIDI parts for that synth to that track. This is just the same as creating a subgroup, except we are mixing MIDI data instead of audio. However, if the plug has multiple outputs, it will need to be wrapped in a rack. Assuming you have set up the plug to send each separate part to its own output, you can create a rack filter for each MIDI track and select the outputs that correspond to that track. Now each track can contain the MIDI clips for that part, along with any effects processing the audio, just as if each part was using a separate synth. Racks can also be configured as an effect send, and unlike the standard auxiliary sends, they will compensate for delays caused by plugs such as convolution reverbs. Start by dragging the plug to an empty track, which will become the return track, and make sure it is properly set up to produce wet signal only. Now right-click the filter and choose Wrap this filter in a new rack filter. Again, the filter is automatically moved into a newly created rack, and a connecting rack filter is left in its place. Hold Ctrl and drag a copy of this rack filter onto the first track you wish to send to the reverb, taking care to drop it after the volume filter if you want to post-fade send. This rack filter should now be set up so that its dry signal is fully up and the wet signal is turned off. This ensures that the rest of the filters on the send track still receive the dry-only signal, while the wet reverb output only emerges from the rack filter on the return track. The send can then be copied to any other tracks that need to share the reverb, and the individual send levels for each track can be controlled using the input level sliders on each send filter. Normally, you would leave the link inputs button on, so you need only adjust one channel. So, a simple rule to remember to configure a rack as a send and return loop: send filters should have all dry level and no wet, and only the return filter should have its wet slider turned up. If a filter has multiple inputs, a rack can be used to provide routing. For example, the Mackie stereo sidechain compressor has 3 inputs, as we can see if we wrap it in another rack. The first 2 are processed and passed onto the outputs, while the third is the key input that feeds the sidechain of the processor. The rack filter that now sits on the bass track instead of the compressor itself defaults to routing its inputs to the first pair of rack inputs, so the compressor is now set up to process the bass. However, nothing much will happen until we send something to the key input. Copy the rack filter to another track. In this case, I am choosing the kick drum track. Dropping it before the volume filter ensures that I can adjust the volume of that track later on without affecting the sidechain processing I am setting up now. Now we need to route one of the inputs to the third key input, while leaving the other unconnected as the kick drum is mono, and then turn off the wet level and turn up the dry so that we still have just kick drum emerging from the outputs. Now we can see that the Mackie compressor in the rack is responding to each kick drum hit and ducking the level of the bass. Plugins that introduce extra latency can be used within racks, but they need to be used with care if you want the latency to be compensated automatically. For example, if we drop a Mackie compressor plug onto a track and check its advance field, we can see that the compressor has added a short 0.7 milliseconds delay, which has been compensated for by shifting the timing of that track by the same amount. Although this delay is too short to be heard as a delay, it will cause phase cancellation if the dry signal is added to the output, which can be heard as a tonal change as well as a volume change. If we wrap this plug in a rack, Tracktion will realise that the entire rack needs to be compensated by the same amount as the plug on its own, so the advance value on that track will not change. However, if we wire the rack's inputs directly to its outputs to provide parallel compression, we hear the same phase cancellation problem as before, and if we check the advance value again, we see that Tracktion no longer knows by how much it should advance the track. This is because there are now two parallel signal paths through the rack, one with latency and one without, and Tracktion has no way to compensate them separately. The easiest way around this is to pass the dry signal through a copy of the compressor, which is set up not to process the signal at all, but which is used just to delay the dry signal by the same amount as the processed signal. Now Tracktion will see two signal paths with the same latency, and it can set the delay compensation accordingly. If you wire the two compressors in series instead of parallel, however, Tracktion is clever enough to know that the advance value should now be set to the sum of the latencies of both plugs. If I add a third plug wired in series, the delays of all three plugs will be summed. If I wire the third plug in parallel with the second, Tracktion will correctly change the advance value back again. But if I wire the third plug in parallel to both the other plugs, delay compensation is broken again, and the advance value will revert to 0. You can therefore build complex structures using non-real-time plugs, and if you take care to make sure that each parallel signal path has the same delay requirements, the total rack delay will be compensated automatically. Likewise, racks that have multiple outputs feeding different tracks must have the same delay requirements for every output for delay compensation to work. For example, when adding a standard auxiliary send to a multiple output drum mix, such as the one I set up earlier, only tracks that you wish to send to the effect need have a send filter. If you need to use a non-real-time reverb, however, you will need to wrap it in a rack as described earlier. But copying the send rack filter to just the snare track, for example, will result in audible delays. This is because the RM4 wrapper rack needs to have the same delay on all its outputs in order for its source tracks to be advanced by the correct amount. So the solution is to copy the reverb send rack filter to all tracks that have an RM4 wrapper rack filter, including MIDI-only tracks, and use the input level sliders to determine which of those tracks actually send to the effect.